Alright, so question 3 asks us to state the range and period of this cosine function. So the range is essentially the y values that the function exists within or covers. That's not a mathematical definition, that's just how I would interpret this question. And of course the period of any cos or sine function is equal to 2 pi on n, and it's how long it takes to complete a full cycle. So that there would be 1 period. Alright, so the y values that it can take, we've simply got, it's translated up 4 units, and then it's got an amplitude of 3. So the range is just given by, so we can go from 4 minus 3 inclusive all the way up to 4 plus 3 inclusive, which is equal to 1 and 7. So that's our range. Now our period is 2 pi on n. Oops, so what am I doing there? That's 2 pi on n, sorry. So n comes from when we have a function in this form. So as you can see, if we look and compare these guys, the coefficient to x, n, is equal to pi on 2. So therefore our period equals 2 pi on n, which equals 2 pi divided by pi on 2. So we can treat this as 2 pi on 1 multiplied by 2 divided by pi. And finally, by cancelling out the pi's, we should get that this is just equal to 4. So our period is 4, and our range goes from 1 to 7. Okay, so question 3b asks us to solve the following trig expression, which involves sine. And in particular, we've got to look at this for x is an element of 0 to pi. So there's many starting points, but the first one I'd like to look at is what's our reference or basic angle. So sine theta, our reference angle, equals a half. So that's what we're trying to find. So to do that, I'm going to use our clever little triangles again. So right angle there, 1, root 3, and 2. In here we have 60 degrees, which is the same as pi on 6. And in here we have 30 degrees, which is the same as pi on, that's pi on 3. And that's pi on 6. So now we need to use so sine of our angle equals O over H, where we know O and H are 1 and 2. That's what we pull from up here. So now all we need to do is go hunting for an angle that's opposite this side 1. So we're looking at this angle here. So our reference angle, or our basic angle, is going to be pi on 6. So if we had sine that hadn't been translated anywhere or anything like that, we just have this going on. So we could draw a line at a half, and we'd find there'd be 2 intercepts per period. So per 1 full revolution. In this case, let's go ahead and write this in our more desired form. So we want sine of n, so let's pull the 2 out the front, of x plus, so if we pull the 2 out the front, we're going to need to make this pi on 6 equals a half. So this guy here is our n, n. So our period equals 2 pi on n equals 2 pi on 2 equals pi. And conveniently enough, that's exactly what our domain is. So our domain is 1 period. Exactly. So that's really handy for us. So with that in mind, what we've now got is from 0 to pi is 1 period. And then we've been translated plus pi on 6, which means we go back just a little bit. So it's going to look something like that, where we're still completing a full cycle between there and there. And we've now got to find out, where does this equal a half? So to do that, what we're going to do is we're going to let 2x plus pi on 3 equal, so where's sign positive? C-A-S-T. So in the first and second quadrants, we've got positive values for all there and sign here. So in the first quadrant, our symmetry is theta, and in the second quadrant, our symmetry is pi minus theta. So we're going to let this equal theta pi minus theta, and hopefully we'll find that that's within this domain up here, and if not, we can just extend it out by adding and subtracting off periods. So we're going to find this is equal to 2x plus pi on 3 equals our reference angle, pi on 6, comma, pi minus pi on 6, so that's going to be 5 pi on 6. So at this stage we'd then need to subtract off pi on 3 from all values, which would immediately take this one outside the domain. So what we're going to need to do is we're going to need to go around a little bit more and find the next value after pi on 6 that sign is equal to a half. So if we keep chugging around our circle around here, we're going to find that that is equal to 2 pi plus theta once we're into the fifth sort of quadrant. So that's 2 pi plus theta. So that's going to be 2 pi plus pi on 6, which hopefully is going to be 13 pi on 6. So again, once we've subtracted away minus pi on 3 from this value and this value, hopefully they'll come back inside our domain. So we get that 2x equals, alright, so that guy there in terms of on 6 is the same as minus 2 on 6. So 5 pi on 6 minus 2 pi on 6 is going to give us 3 pi on 6. And then 13 pi on 6 minus 2 pi on 6 is going to be 11 pi on 6. So next up, we've just got to divide off by the 2. So divide off by the 2, and we should get that x is equal to, so that's 3 pi on 12, which is going to be pi on 4. This is going to be 11 pi on 12. Oops, sorry, 11 pi on 12. And they are your solutions over this domain.